In this lesson, we're going to look at how can I represent a situation with an algebraic expression. And you want to remember that an algebraic expression is something, it can be something as simple as 3j. That means 3 times a number. Or it could be like 2x plus 7. So 2 times a number and then add 7 to it. So again, that's what an algebraic expression is. And we're going to look at real-world situations that you would use one of these algebraic expressions or another one you have to write to represent. In this first situation, it says that Rosa has 5 fewer bracelets than Maria. So in order to do this, you first want to use what we call let statements. A let statement is where you simply write let and you pick a variable. So I'm going to let R equal the number of bracelets that Rosa has. So I wrote a let statement that says let R equal the number of bracelets Rosa has. Then you create a second one to say, what do I want to equal the number of bracelets that Maria has? That's the other thing we need to have here. So we could say, let M equal the number of bracelets Maria has. Makes that look a little better. Okay, so I have two let statements. We are going to have R equal the number of bracelets Rosa has, M is going to equal the number of bracelets Maria has. Now I'm ready to kind of write an algebraic expression, knowing that Rosa has 5 fewer bracelets than Maria. So I know that Rosa is going to equal 5 fewer bracelets than Maria. So that means we start with M, and we need to do 5 fewer, we take away 5. We take away 5. So R equals M minus 5. And no matter what M is, as long as so then what might happen in a problem is it might give me R or M. So I'm going to kind of work you through that example now. If it said that Maria, or M, equals 7, right? Then we would simply substitute in, and we would do R equals 7 minus 5, R equals 2. Problem solved. Pretty simple. Sometimes it might tell you the other one, though. It might tell you instead, it might say R equals 2, right? And so if R equals 2, I'd say 2 equals M minus 5. And to figure this one out, what you need to do is work backwards and say, well, M minus 5, to get there, I really need to figure out what M minus 5 is. If I just add 5, that'll give me just M. So if I add 5 to both sides of the equation, it'll end up balancing out. And then so what I end up with is 2 plus 5 is 7, and that's going to equal M, because minus 5 and plus 5, those are additive inverses, so they cancel out and equal 0. So this is going to be 0. So it just ends up equaling M plus 0, which is just M. Therefore, we know that 7 is what equals M. And we know that that actually is true because over here, when R was 2, M had to be 7. So that's how these variables work together in creating this algebraic expression. And again, the point is really just to get to this point. So the other stuff is cool, but if you can get to here, you're good. Here's another problem that we're going to work through. Terrence has 1 fewer sibling than Casey. Colby has 3 more siblings than Terrence. So we want to set this up to figure out, we use an algebraic expression with various variables here. What I'm going to start out doing is I'm going to make a let statement for our variables, which seem to be T for Terrence, the number of siblings that Terrence has. I'm going to do one for Casey and one for Colby. So you can see here I've written 3 let statements. Let T equal the siblings Terrence has. Let C equal the siblings Casey has. Let K equal the siblings Colby has. And we want to kind of look at what's the relationship between these variables and how could we figure out the number of siblings each one of them has if we were given some of them. So first you'd say Terrence has 1 fewer sibling than Casey. So I know that T is going to equal C, the number Casey has, minus 1. That I can write from this expression, from this situation. Colby has 3 more siblings than Terrence. So then K is going to equal Terrence plus 3. So what I can do from here is I could actually combine these and maybe I can use them both to figure out the total problem if I'm given one. So say, for example, they tell me that, I say I'm given Terrence. Terrence or let's not start with Terrence. That'll be kind of the easy one. Let's start with Casey. Say you're given Casey has 5 siblings, okay? So C equals 5. You substitute that in and do T is going to equal 5 minus 1. T is going to equal 4. Now that I know what T equals, I can substitute into the other expression, or the other equation, and because it has an equal sign. So then I substitute in and I say K equals 4 plus 3, K equals 7. So now I have figured out all 3 variables, C, T, and K, just by being given one of them. In this case, I had to set up 2 separate equations and then work through them to figure that out. Another way you could do this is you could actually substitute in, knowing that T equals C minus 1. I can actually change this expression to know the relation between Colby and Casey is that K equals C minus 1 in parentheses, because I'm replacing the T with what it equals. T equals C minus 1. C minus 1 plus 3, and then if I'm given the 5, I can substitute that in. I should end up with 7, just like I did originally. So if I put 5 minus 1 plus 3 equals K, and then 5 minus 1 is 4, plus 3 equals K. K is going to equal 7. So again, you can substitute in the actual expression in within another equation and still use that to work through the problem. So here are 2 examples. We'll practice some more with this in class and representing situation using algebraic expressions. So it's how can I represent a situation with an algebraic expression? Hopefully I have a better sense of how to do that.